We are looking at rational exponents. So we have a to the 1 over n, a to the m over n, and a to the negative m over n. So basically, what happens in the first one, 1 over n, we're saying that n then is actually the same thing as the index in a root. So if you're looking at 1 over 2, it would be the square root. 1 over 3, it becomes the cubed root. A to the m over n means that we can do one of two things. The n, of course, is still going to be your root, but the m can either be put on the inside inside the radicand, or it can be put on the outside. So I typically make that decision when I'm looking at the problem, whether or not I can take the nth root of whatever the number is. And we'll do an example about that, and I'll show you the two ways you can solve that. And then on this one, because it has a negative exponent, we have to move it. We've already learned this before. Move it down into the denominator. And as long as, of course, this is not going to get you a 0 in your denominator. Alrighty, so let's go look at some examples. So our first example, example 1, part A, we have 4 to the 1/2 power. Well, that means the same thing as if we take the square root, because the 2 is the same index, of 4, which will get us 2. For part B, if we have 64 to the 1/3 power, that 3 in the denominator of your fraction exponent means that you're taking the cubed root of 64. Cubed root of 64, using your calculator, you will find that that is 4. If we have x to the 1/4 power, that's the same thing as the 4th root of x. So basically that denominator, because we only have a 1 on top at this point, becomes the index on your radical. So if we have 81 x to the 8th raised to the 1/4, because of the parentheses, that tells us the whole thing is the 4th root of 81 x to the 8th. So the 4th root of 81 will get us 3, and x to the 8th, 8 divided by 4, because it's an exponent, will get us 2. So it will be x squared. You can also break that down as we have in previous lessons and write it out, factor it all out using a factor tree, and you can also circle them. But these are perfect ones, so that's why I'm not doing that this time. All right, we have 5y to the 1/3. Notice that it's not got parentheses this time. The only thing getting the 1/3 power is the y, so we'll have 5 cubed root of y. So pay attention whether it has parentheses or not. All right, the next example we are going to look at, this will be example 2, part A. We're looking at 8 to the 2/3. So on the previous one, we had everything was to a 1 over another number, so that we could just focus on the bottom part. Now we're also looking at the top part. So this is the one we can do two different ways. First of all, that 3 at the bottom still becomes that cubed root of 8, and we can do it, whoops, hang on a second, I skipped a step, so let's cross that out. So let's look at this as 8 to the 1/3 being raised to the 2nd power. Because remember, if you recall, 2, because you're raising it to a power, it gets multiplied. So 2 times 1/3 would get you 2/3. So we can actually write this as 8 to the 1/3 squared so that you can understand what's going on with it. We don't have to do this, but I want you to be able to see where all the values are coming from. So now we know from the previous ones, 8 to the 1/3, that means the cubed root of 8, and then I can square it. The cubed root of 8, 8 is a perfect cube. That is going to get us 2. 2 times 2 times 2. And 2 is getting squared, so it is 4. We could also do this as 8 squared being raised to the 1/3 power. So you can put it either way. Because 8 was a perfect cube, I like going this way because it keeps the number smaller. If I do it this way, I am then 8 squared is 64, and 64 is being cubed rooted. So 8 squared is going in there, and then we're taking the cubed root of it. This then becomes 4. So I end up with the same answer, but just understand that to me this is better because the numbers are smaller than going with the other route. But either way will work. All right, let's look at another example. If we have 4 to the 3 halves, this would be the same thing as the square root of 4 to the third. Square root of 4 again is 2 to the third, which will get you 8. So again, because I could take the square root, I'm going to go that way. If I can't, then I'll go the other. All right, C, we have negative 16 to the 3/4 power. This will get us, notice it's not in parentheses, so the negative is on the outside, and then it's the 4th root of 16 raised to the 3rd power. Again, I can take the 4th root of 16. That is going to be 2, and 2 is being cubed. The negative is just tagging along at this point. 2 cubed will be 8, so we'll end up with negative 8. So here we have negative 27 to the 2/3 power. So I can do the cubed root of negative 27, so I'm going to do that rather than square 27 and then take the cubed root of that. So it will be the cubed root of negative 27 being squared. Cubed root of negative 27 will be negative 3. Negative 3 squared is 9. And our last one on this part is if we have 1 over 9 to the 3 halves power. Well, I can take the square root of 1/9, so I'll do the square root of 1 over 9, and then I will raise it to the 3rd power. The square root of 1/9, they are both perfect squares, so that'll end up with 1 over 3. Square root of 1 is 1, square root of 9 is 3, being raised to the 3rd power. 1 to the 3rd power is still 1, 3 to the 3rd power is 27. All right, let's go look at some more examples on using some different rules. All right, this will be example 3. And on example 3, part A, we are looking at 16 to the negative 3/4. So this is our negative exponent. First thing we need to do is move it to the denominator to make the exponent positive. Now we can change this to the 4th root of 16, and I can take the 4th root of 16 and then I will cube it. So we'll have 1 over, the 4th root of 16 is 2, and 2 will be cubed, and 2 cubed is 8. If we have negative 27 to the negative 2/3 power, again it's 1 over negative 27 to the positive 2/3 power. We don't change this negative, only the negative on the exponent. That's the only one that changes is the exponent on the outside. All right, so I can take the cubed root of negative 27, so 1 over the cubed root of negative 27, and then I will square that answer. The cubed root of negative 27 is going to be negative 3, and when I square that, I get 9. If I look at x to the 1/3 times x to the 5/3, if you recall, we added our exponents. So this will get us x to the 1/3 plus 5/3 because they are both positive, and when we are on the same level, we're going to add the exponents. So we're going to add those two exponents together. So that will get us x to the 1 plus 5 will get us 6/3, which is x. 6 divided by 3 is 2. For this example, we have x to the 1/2 times x to the 1/3. Again, we're going to add our exponents, so this will get us x to the 1/2 plus 1/3. The difference here between here and here is that here we had a common denominator and here we do not. So we need a common denominator. So the common denominator between 2 and 3 will be 6. So x to the 1/2 is the same thing as 3 over 6. And 1/3 is the same thing as 2 over 6. Now we can add those together and we get x to the 5 over 6. All right, let's look at another one. If we have y to the 1/3 over y to the 4/3. So here we're going to do subtraction because we are doing division. So multiplication, we add them. Division, we're going to subtract them. And we can see that we have 1/3 up here and we have 4/3 down here. So there's more of them down here. So I'm going to move the top down. You can move them all the way up. Figure out if you have a negative exponent or not. But I like to try and figure out where they might land. And that way I can save a little bit of effort. But you can move it up and then move it back down if you want to. So if I move that down, that leaves me with a 1 on top, y to the 4/3 minus 1/3. So this will get us 1 over y to the 3/3, and 3/3 is the same thing as y, so 1 over y will be our answer. If we have y to the negative 4/7 times y to the 6/7, we're still going to add. So we have y to the negative 4/7 plus 6/7. Well, 6 minus 4 will get us 2, so y to the 2/7. All right, let's look at some simplifying. So this will be example 4, and we are going to simplify. So if we have the square or the 6th root of x to the square, we're going to use exponents to do the simplifying. So we're going to kind of go backwards of what we were doing earlier. So because we have the 6th root of x to the square, we know that the 6th root is the same thing as an exponent of 1/6. So this is like x squared being raised to the 1/6 power. If you recall with our exponents, that when they're being raised to a power, we multiply them. So this will be x to the 2/6, which will be the same thing as x to the 1/3 because it reduces, which is the same thing as the cube root of x. So we're using the exponent rules to simplify our radical. So now we have the 4th root of r squared s to the 6th power. So again, that's r squared s to the 6th being raised to the 1/4 power because of the 4th root. So that means we're raising it on both. So we're going to multiply 2 times 1/4 and get r to the 2/4, s to the 6/4. Well, 2/4 reduces down to 1/2, and 6/4 reduces down to 3/2. Well, they both have that index down here of 2, that denominator, which will become the index on the radical. So I'm going to change this to r to the 1st, s to the 3rd, and raise it to the 1/2 power. And then I can change this into a radical. It'll be the square root of r s cubed. Now, I do realize that the s could reduce because we have 3 of them. We're taking the square root. But we're just working right now in this example on reducing using the radicals instead of just worrying about taking the actual square root of it. All right, our next example. So example 5, we want to write as a single radical. And we want to do this using our exponents. All right, so we have the square root of x times the fourth root of x. So we have two terms, and we want to write it as one term. So in order to do this, we're going to remember square root of x is the same thing as x to the 1/2, and it's being multiplied times x to the 1/4. Remember, we have x to the 1/2 plus 1/4 because we add our exponents. Got to get a common denominator, so x to the 2/4 plus 1/4, because 1/2 is the same thing as 2/4. When we add that together, we get x to the 3/4, and then we can rewrite this as the fourth root of x cubed. So this is one of those where, because we can't take the fourth root of our x, we will just put the exponent inside, because it doesn't make any sense to put it on the outside. All right, let's look at our last example for this section. So we have the square root of x over the cubed root of x. Well, this is still x to the 1/2 over x to the 1/3. So in order to figure out where they're going to go, we need to get them a common denominator. Again, with 2 and 3, we're going to have a denominator of 6. So this will be x to the 3/6 over x to the 2/6. So we're just converting 1/2 to a common denominator of 6 and 1/3 to a common denominator of 6. Well, now I can see I have 3 of them on top and 2 of them on the bottom with that same denominator. So I have more of them on the top, so I will move it upstairs this time, or up to the numerator. So we'll have x to the 3/6 minus 2/6, because with division we do subtraction. This will get us x to the 3 minus 2 is 1 over 6, which is going to equal the sixth root of x. So that's using our exponent, our fractional rational exponents. And so different rules you just got to know and understand on how to do those, and pay attention to what they're asking you, because we couldn't leave it like this time because they want us to write it as a single radical. Just use the exponents to do so.